3, 2, 1. Now, diagram shows a horizontal table which has a 2 kilogram mass placed, a 4 kilogram mass, and 1 kilogram mass hanging over either side. The coefficient of friction, mu, is a half. Find the common acceleration. So it's given away part of the formula. this is acceleration A. This one has acceleration A, and this one has acceleration A. Now, I'm going to use the letter T for there's 2 different strings. It's not 1 string, it's 2 strings. You get me? So T is going to be the tension in the first string. Are we happy enough for that? And it's pulling the 1 kilogram mass upwards, but it's also slowing down the 2 kilogram mass from going to the right. Does that make sense? It's sort of like hanging off the back of it as it's moving in this direction. So it's actually slowing down. On the other side, we're going to make this tension X. Is that right? Tension in the second string is X. And it's on its way downwards, agreed? With 4G. And this one is 1G acting against it. And then X will actually pull the 2 kilogram mass to the right. And we'll pause. So X is the tension in the second system, all right? So let's start with the 1 kilogram particle. Up or down? Up. Which means what? Up. T minus y. Okay, so would you all agree with 1A? Would you all agree with T? And would you all agree with 1G? Done. First one down. Okay, and that's nice and handy there. Second one, what do we think? Any ideas? Huh? We'll go for the 4 kilogram one first, all right? Let's do the 4 kilogram one, it's easy. So up or down? Down. So F is going down. And what's weight minus? Okay, T. Is that right? So what's this going to be? 4A equals? Now it's not T though. It's actually X, isn't it? Because the tensions aren't the same thing. So there's 2 tension variables. We're like, okay. They're not compatible with each other, are they? It's like one of them's apples and the other one's Android. They can't talk to each other because they have different tension systems, yeah? Now we're going to go for the next particle. Okay? And what I'm just going to do is just going to draw this on the heat, that's a circle. Now, we're just going to draw it in a separate diagram for a minute. You'll see this in some of the past papers that allows you to draw the marking scheme on separate diagrams, okay? So here we go. Would you all agree it's X moving it to the right? Take away T. But we forgot about something. Forgot about friction. So we need the R value. And the R value is the same as 2G. See the way it's not sinking into the table? See the way there's no acceleration up or down? That means they're in perfect balance. So your R value equals 2G. Your R value therefore is 19 points. I suppose I keep it as G because everything else is in terms of G. So I'll leave it alone for a minute. Now what's friction, guys? Half of 2G, which is G. 1G in this direction. You go with that? Now I have enough information to do the question. So here we go. Okay. F, what direction is F going in? To the right. Which means it's 2A going to the right. Which means it's X going to the right. Take away. Tension going to the left. Take away. 1G going to the left. Do you see those arrows I'm using? You don't have to use that. I'll just use it to explain myself. Anything going to the right is positive, and anything going to the left is negative. I'll just use it myself. You don't see that in marking schemes or anything like that. Now, here we go. So, here's how you should do this system, right? There's many ways to solve this, okay? But here's what I would do. I might let you guys take this away now in a second, all right? What's the goal of the question? It wants me to find A, it wants me to find T, and it wants me to find. Now here's what I want you to do. I want you, using the red equation, get T on its own. When you get T on its own, sub it in here. In the black equation, get X on its own. And once you get X on its own, sub it in here. And you'll find you'll be able to calculate the A value then. Okay, off you go. Okay, just get myself a bit of space back. Okay. And many people got a T equals A plus G. That's for the red one. And then X, when you move X to the left using the black equation, X equals 4G minus 4A. And then sub into the main one. So 2A equals X, which is 4G minus 4A. Minus T, so minus A minus G. Minus another G. I think what we're going to get is 2G minus 5A equals 2A. 7A equals 2G. A equals 2 over 7G. And 2 over 7G is 2.8. S minus 2. Everybody cool with that? Well, it's 2 over 7 times 9.8. Gravity's 9.8. Okay, now this one here, everybody see tension? Tension is 2.8 plus 9.8 because gravity is 9.8. What do we get that as? 12.6? Anybody thought? 12.6? Okay. And then X is 4G, so X is 4 times 9.8. Take away 4 times 2.8. Then we get 28 for that. 28. Now 28 newtons because it's a force. So what we're doing is, what we're thinking is happening is we're going to call this tension T. And the full system, would you agree, is going across with acceleration A. It's either that or it doesn't move. Would you all agree with that? Either moves to the right or it doesn't move at all. Now, call that 3G. The tension is pulling the whole, it's only pulling the 3 kilogram particle. Do you get what I'm saying? Because the 3 kilogram particle is the only one that's connected to the same rope as the other 3 kilogram particle. However, that means we need a new tension, which we'll call X. This X is pulling the 2 kilogram particle to the right, but it's also slowing the 3 kilogram particle to the left. And we also have negated friction forces on both of them, isn't it? 1/4 on both of them. Agreed? So a friction force here and a friction force here. Okay, time to draw our separate diagrams. Once we draw our separate diagrams, we won't need the original. Let's get easy marks on the board. Let's do the 3 kilogram particle falling. Get some easy wins. 3 kilogram particle, 3G weight going down. What's going up? Tension. And you only have to show the forces. Showing the acceleration, you don't actually have to do that. But that's done now, all right? So that's that part done. I can sort of like just sort of blank this out now. Don't even need that anymore. You're gone. Okay. So you see the way I'm thinking about it. That's gone. Okay. I'll do the 2 kilogram particle now, okay? Here we go. Now, is the 2 kilogram particle sinking into the is it sinking into the table? No. So it has 2G going down, or where R does equal 2G. You're completely correct about that. What's pulling it to the right? X is pulling it to the right. What's making it go to the left? Friction, which is mu r, which is a quarter r. And we all know a quarter r is a quarter of 2 G. I'll do that here now. Mu r, actually, in a second. I'll do it in a second. Okay, you okay with that? Okay. Now, okay. Next diagram is going to be the next diagram is going to be the 3 kilogram system. Take the 3G one. Now, what do we think about the 3G one? It's the more complicated one. Okay. Reaction force N. Why am I calling it N? Because R is already used. Yeah. And then what are we calling it? 3G? What's pulling it to the right? T is X to the right. Oh, sorry, it's T to the right. Yeah, you're right. T to the right and X to the left. But there's something else to the left as well. 1/4 N. You all right? Now, here we go. Okay. So we have all that done. Now that's worth like 5 to 10 marks sometimes, depending on the size of the question. Now, just going to get rid of all this from our board space. And we're good. Now, here's what we're going to do next, guys. We're going to start off with the easy one. Which one's the easy one again? The one hanging downwards, yeah? Is it going upwards or downwards? Downwards, which means it's 3A going, which equals 3G going downwards minus T. Once again, those don't have to worry too much about the arrows, okay? So go on. Now what about the next one? We'll do the red one, the 2 kilogram one, okay? So we all agree force is going right, which is what? 2A. You're right about the X though. X drives it to the right. What makes it go left? 1/4 R. And we're going to sub out R with 2G. And what happens when we do that? Would you all be happy with G over 2? What? 0.5 G? Or G over 2? Okay. Decimals are okay, provided you don't have to round them. If you have to round them, don't do it. Use a fraction then. Okay. Now, we're on to the, doesn't have to color code these, but, okay. All right, blue one. Have you seen the blue one? Just the 3 kilogram part of what we're going to do now. Right, now what do we do here? Yes. No idea what happened, but we're just going to roll with it. Okay. So what happens? The blue one, yeah? So what's the blue one going to be? Sorry, my forms just went all over shop there a minute ago. Okay, I think we're good now. Okay. So we have this one and this one so far, don't we? Okay. Now, next one. The blue one. So what do we get here, guys? Would you all agree with 3A going to the right? Who's leading that? T minus. I did minus X already. 1/4 N, but 1/4 of, which is minus point. You okay with that? Now we're going to do the same technique we did last time. What letters do you want me to sort of isolate? Well, yeah, let's get x and t on their own. So I'm just going to get rid of the f's on the other side. Now this comes a lot easier looking. Then we're going to get t on its own. So t is 3g minus 3a. X is 2a plus 0.5 g. And then we're going to sub it into the bottom equation. Once again, let's need a bit more board space. What are we going to get here? 3a is 3g minus 3a, yeah? And after that, what is it? 2a minus 2a minus 0.5 g and then minus 0.75 g. Okay. Now, would you all agree that's 5a minus 5a? Sling it to the right, 8a. And then we have a 3g, take away 1.25g. Everybody happy with 1.75g? Everybody, here's what we're going to do. You're going to multiply 1.75 by 9.8, and you're going to divide the answer by 8. They give me an answer for the a value. 2.143, 75, 144. Okay. Just that, we're after the common acceleration. Done. Next thing we're after is the tension. Now, do you remember the answer you gave me in decimal? Is there a fraction for that? Could you press change and give it? Yeah, do it like that. 343 over 160, because you don't have any rounding issues then. Now, here's what we're going to do. We have to find out what t and x are, don't we? So we're just going to go all the way back to t, and t is the green equation. So it's 3 times 9.8, take away 3 times 343 over 160 AD. I'll give you that job. Okay, CS or KS. Yeah. Here's your one. 2 times 343 over 160 plus 0.5, 9.8. So AD is going to give me the green one. What you get? 735 over newtons. Yeah, and roughly as a decimal. Okay. KS 147 over 16. Yeah. And as a decimal. 8, 5. So yeah, does that make sense? That t. Oh well, whoa. One of them's x. That's x. Does it make sense that x is a lot smaller than t? Let's go back up to our initial diagram and think. Which one's x again? X is only pulling the 2 kilogram particle, right? While t is technically pulling. Yeah, so that makes sense, doesn't it? So for future, you can figure out which one's going to be bigger right at the start. And if your answer doesn't match that, then you know you're wrong.